So in this problem, we're told to evaluate the integral from 0 to pi over 4 of 2 times secant squared of t dt. And so let's just first rewrite our integral. Go from 0 to pi over 4 times 2 secant squared t dt. So the first thing that we need to do here is take the antiderivative of our function here. So 2 times the secant squared of t. And so if you recognize here that, well, you should know that the derivative of tangent of t is going to be secant squared of t. And so you can recognize that here. So if we're trying to take the integral of it, or the antiderivative of it, it's just going to reverse backwards. So it's just going to be the tangent of t, and we're multiplying by 2. So the antiderivative of this is just going to be 2 times the tangent of t. And so now that we got that, we just got to check it from pi over 4 to, or 0 and pi over 4. So what we're going to do is plug in pi over 4, get a value, and then subtract 0 plugged into this. So if we plug in pi over 4, 2 times the tangent of pi over 4 is, well, we know that the tangent's going to be equal to sine over cosine of our value. So sine of pi over 4 times the cosine of pi over 4. So based on the unit circle, we know that the sine of pi over 4 is going to be rad 2 over 2. And the same goes for cosine of pi over 4. So it's also rad 2 over 2. So if we got the same thing over itself, it's just going to be 1. So we know the tangent of pi over 4 is going to be 1. And then it's 2 times 1, right? So 2 times 1, which is just 2. So we know when we plug in pi over 4, it's just going to be 2. And then we subtract, and we're going to plug in 0. So we're subtracting whatever 0 is plugged into this. So times the tangent of 0. So tangent, once again, is the sine. So it's the sine of 0 over the cosine of 0. The sine of 0 is just going to be 0. The cosine of 0 is 1. So 0 over 1 is just 0. So it's just going to be 2 times 0. And we know that 2 times 0 is just 0. So we're going to be subtracting 0. So 2 minus 0 is just going to be 2. So this right here is going to be the answer to this problem.